Chapter 7, Lesson 5, Similar Triangles and Indirect Measurement. You will be able to solve problems involving similar triangles. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So since angle A is congruent to F and B is congruent to G, I can automatically say that the two triangles are similar. Determine whether the triangles are similar. If so, write a similarity statement. The first thing we need to do is find the missing angles. I already know that they each have a 62-degree angle. That's one angle pair. But I need another angle pair, and 48 is not congruent to 70. So let's find the missing angle. Let's find angle G first. I know that when you add up the measures of a triangle, it equals 180 degrees. So 48 plus 62 plus angle G equals 100. 48 plus 62 is 110. 110 plus G equals 180. Minus 110. G equals 70 degrees. And let's find angle B. Actually, we don't have to find angle B. I already have the two angles that are congruent. So these two triangles are similar. So we can say triangle, and again, make sure you're going in order. I'll go EFG. The symbol for similar is a tilde. Triangle. So I went E to F to G. 62 to 48 to 70. So 62, this must be 48 to 70. So triangle ABC is how we write it. And our reasoning behind here is because at least two angles are congruent. We'll say at least two corresponding angles. Letter B. Well, they're both right triangles, which means this is 90 degrees. And this is 90 degrees, which gives us one congruent angle. And then we have a 35-degree angle and a 25-degree angle, so we need to find a missing measure. Let's go ahead and find N. So we have 90 plus 35 plus angle N equals 180 degrees. 90 plus 35 is 125. 125 plus N equals 180. Subtract 125. And we get N equals 55 degrees. Well, I have a 35 and a 55. Here I have a 25. I do not have two angles that are congruent, corresponding angles. Therefore, they are not similar. So, the triangles are not similar because, let's move this up here. The triangles do not have two congruent corresponding angles. Letter C. Determine whether the triangles are similar. If so, write a similarity statement. So here we have a little bit of a dilemma. We have the 110 degrees in each, so it definitely tells me that we have at least one angle, but we have no other measures. However, what we do have here are two intersecting lines. And the two intersecting lines form these angles across from each other, which are vertical angles. And what we know about vertical angles is that they're congruent. So, let's jot that down. Angle JKH is congruent to angle MKL because they are vertical angles. And with that in mind, we can now say the triangles are similar because at least two corresponding angles are congruent. So you don't have to know the measure of the angles either. One type of indirect measurement is shadow reckoning. Two objects and their shadows form two sides of right triangles. In shadow problems, you can assume that the angles formed by the sun's rays with two objects at the same location are congruent. Since two pairs of corresponding angles are congruent, the two right triangles are similar. You can also use similar triangles that do not involve shadows to find missing measures. So here we have a fire hydrant, 2.5 feet high, that casts a shadow of 5 feet. How tall is the street light that casts a 26-foot shadow at the same time? Let each represent the height of the street light. We are going to set up a proportion. So this length here of 5 corresponds with 26. And then 2.5 corresponds with H. And notice how I wrote the fire hydrant first. So this top line here is the hydrant. And this bottom line here is the street light. And it's the same on this side as well. So to solve a proportion, we cross multiply. H equals 26 times 2.5 is 65. Divide by 5. H equals 13, and that's in feet. So 13 feet. Letter B. In the figure below, triangle DBA is similar to triangle ECA. Ramon wants to know the distance across the lake. So 40 corresponds with D. And this is where it gets a little tricky. We have this length, but we do not know the entire length. We know this little bit here, but not the entire thing. So let me redraw this here. We have two triangles. We have A, D, B, where this measures 40, and this measures 320. We then have a bigger triangle, which is A, E, C. This length is D, and we don't know this length right here. But I know that this length is a total of these two lengths put together. So let's add those two lengths. 320 plus 162. So this length is actually 482. So this 482 corresponds to the 320. And we wrote our smaller triangle first measure, our triangle measure. So 320 goes first here, and then 482. Now let's cross multiply. 320D equals 19,280. Divide by 320. And we get D equals 60.25. And the unit is meters. Letter C. At the same time, a 2-meter street sign casts a shadow that's 3 meters long. A nearby telephone pole casts a 12.3-meter shadow. How tall is the telephone pole? So 2 corresponds with H. And 3 corresponds with 12.3. So we have 2 over H equals 3 over 12.3. Cross multiply. 3H equals 24.6. Divide by 3. H equals 8.2, and the unit is meters. Letter D. How tall is the tree? 0.3 on the dog corresponds, the shadow corresponds to the 2.2 tree shadow. 0.45 height of the dog corresponds to the height of the tree. So we have 0.3 to 2.2 equals 0.45 to H. Cross multiply. 0.3H equals 0.99. Divide by 0.3. H equals 3.3. And once again, we are measuring in meters.